1 in 5 hospital patients, 20% over 65 experience delirium. About 6%, or 5.8% of hospital patients over 65 suffer from both a UTI and delirium at the same time. In subjects with a UTI, delirium rates range from 30% to 35%. Use this information to estimate the probability that a patient who is over 65 has a UTI given the patient is suffering from delirium. Okay, so it's a probability question because of this phrase here, right? And they're only looking at one randomly selected patient. And then they go on to use this phrase given, right? So, or word given, or given that, right? So when I see that combination of items, right, the problem's asking me for a probability, they're only selecting one member of the population at random, and then they talk about a given that condition, it leads to or points to conditional probability. So I need to write out the formula then for conditional probability for this problem. So I'm going to write first that it's the probability that a patient has a UTI, so put that first. By the way, a UTI is a urinary tract infection. And then it says given that, for the given that phrase, we'll put a vertical bar up and down, and that vertical bar is basically indicating the phrase given that, right? So it's saying behind this bar is the given that condition, and then it says given the patient is suffering from delirium, so we're going to use D for delirium to represent that. So that's the probability statement. We don't have the formula written out yet, but the statement is going to be a great help in writing out the formula. Okay, so when you want to write out the formula for conditional probability, the way this is done is that you create a fraction bar, and you're going to be dividing two probabilities. The numerator is the probability that both of these things occur at the same time. Both of these things occur at the same time. So in other words, it's the intersection of the two. So you're going to say UTI and delirium in one patient at the same time. So it's the probability you find these things occurring at the same time in a patient. That's what we need to know. And then for the denominator, it's just the probability of the second thing in your statement. So it'd be the probability of, in this case, a patient suffering from delirium. All right, so this is the classic formula for conditional probability filled in. You know, if a problem in conditional probability also provides a table of data, we don't even have to write out this formula. It turns out there's an easier way to solve those problems using the formula, but not actually writing it out explicitly, because it turns out that it'll actually be easier to not use the formula in those cases. But here we have no table of data, so this is the best approach to solve the problem. Now, what we have to do is simply read the paragraph again and try to find these probabilities. You'll notice that they gave us several percentages, right? We have 20%, 5.8%, 30%, and 35% given. We have to know which ones are useful and which ones aren't useful. So this is a matter of critical reading at this point. So let's go through and see if we can find the things we need. For example, probability of UTI and delirium. Do we have a probability statement somewhere in this paragraph that tells us the probability that both of those things occur at the same time? Well, if I read this statement, it says 5.8% of hospital patients over 65 suffer from both a UTI and delirium. And there it is. That's the number we need, because it says they're both happening at the same time in a patient, right? So that would be 5.8%. You could write that as just 5.8% as long as you use percents throughout the fraction. If you put it in the numerator as a percent, you got to make sure the denominator is also a percent, because you're going to want those percent symbols to cancel out. All right, what about the denominator probability? Do we know the probability that someone suffers from delirium? Is that known in the paragraph? Do they tell us that? Well, it does say 1 in 5 hospital patients, that's 20% over 65, experience delirium. So that's pretty explicitly given, right? 20% is the denominator. The probability that a patient in this population experiences delirium is 20%. All right, and from there, it's just a matter of division, right? The percent signs will cancel out, and when you divide 5.8 by 20, you get 29, or 0.29, I should say, and then you'll end up with 29% when you convert it to a percent. And so that's the answer to our question. Looks like the probability that a patient has a UTI given the patient has delirium is 29%.